Hello everyone, this is Gautam Kedia from IT branch presenting you a PPT on Sar Image Colorization. So Sar Image Colorization is a part of remote sensing Gen AI, which is our project. So what is remote sensing Gen AI? So remote sensing is an advanced technology which is used in satellites to gather the information about the Earth surface. We're gonna use this for various applications such as Sar Image Colorization and crop classifications and many more, and there are many applications of it. We'll see it later. Now let's go on synthetic aperture radar, which is SAR. So what is SAR? SAR is an advanced remote sensing technique that uses radar signals to produce the detailed images of the earth surface. So what are these images gonna do? These images are basically grayscale images, which are very similar to black and white images. So what is SAR used for? So the best benefit of SAR is it catches perfect pictures even in the day and in the night, even though there are any weather conditions. So let us look what are grayscale images. So as we see here, this is a grayscale of grassland, barland and urban. So grayscale are fully rich of data of the ground images, but the problem here is they are not colorized. So as we see here, all these three images are grayscale, but we can't understand what is which. So this thing is gonna either, so we are gonna do this thing, that is colorization of SAR images. So what are the main components in our project? So for the front end we're gonna use Flutter. Obviously we're gonna use Flutter as it is a mobile application, and using APIs such as Fast API, Flask server, we're gonna connect it to the backend, and the backend we're gonna have Firebase authentication and Firebase database, and we're gonna use Gen AI models for this SAR image colorization and crop classification. There are uh, various models such as VGC16 model. We're gonna use it, and also pix to pix scan. That is also a model for SAR image colorization. Let us look at the system architecture. So mainly in the client side, the Flutter is used for the front end and user interaction, which the user will give an media, which is nothing but a photo from the gallery. So using the API, we're gonna connect it to the Firebase authentication, and also for the Gen AI models, we're gonna use the APIs. And all the data is stored in the Firebase database itself. Now let's look at the roles in the app. There are mainly three roles. One is end user and the admin, and the third one is the developer. End user are nothing but the government, the farmers, and the flood detection management team, the disaster management team, who will look after the flood detection area and the SAR images. And the admin is the one who manages the data regularly. And the developer, as we know, in this fast changing of the world, we need developers who will adapt to the new updates coming. So that thing will be done by the developer. And what are the interfaces developed? We mainly have the user login and sign up interface. We're going to use the Firebase authentication for that. And the image upload interface, we're going to have two options, which is SAR image colorization, crop classification. Image upload interface is what we gonna use a image picker in the Flutter app, which helps us to pick a image from the gallery, and the result will be displayed obviously. Now let us the dataset used in SAR image colorization. So there is a dataset named as Sentinel-1 and 2 image pair, SAR and optical, which is present in Kaggle. So what is this? This mainly consists of four classes, which is agriculture, grassland, bareland, and urban land. These four contains subdirectories which are S1 and S2. S1 are the grayscale images, S2 are the ground truth images. So we're gonna use pix-to-pix GAN to process the data. Now let's look over the logic of this whole project. So what is the business logic mainly? Whenever there is a disaster or a flood detection, the flood detection team can obviously take use of it. The agriculture, the farmers will take use of it for the crop thing. All this will be the business logic. Coming to the pix-to-pix scan. So as we know, we are going for the SAR images. We are gonna use pix-to-pix scan. So what is a pix-to-pix scan? This is mainly a combination of discriminator and a generator. So we'll learn about discriminator and generator now. What is a generator? Generator is a combination of encoder and decoder in which will provide the grayscale image to it. what will the generator do is it will create a generated image of this grayscale image, which is the colorized image. Now this is generating the image. Then what is the use of discriminator? What is the use of discriminator is will give the generated image and also the ground truth, which is the real image. And the generate discriminator will try to uh, unequalize them, which is nothing but it will try to say which is a generated or a fake image. That is the point of discriminator. And the generator, we are using the unit model. In the discriminator we're gonna use patch. So as we see in the image, so this is the generator. In this we provide the grayscale images. It creates a image which are fake images. Now these fake images and these are the real images. Now these fake images and the real images are given to the discriminator. Now it will try to predict which is a which is a generator and which is the real. Now there is basically a research paper for the pix-to-pix scan. In that all these things are given which are used in pix-to-pix scan, which is we're gonna use the Adam solver, and the learning rate should be 0.0002, which will help for the learning rate. The movement parameters beta 1 and beta 2 should be 0.5 and 0.999. The patch gun should be of 70 into 70. All the ReLUs are Rike ReLUs with a slope of 0.2. So these are the number of train epochs we have done so far, and this is the FID score we are calculated here. Now coming to the VGC16 architecture. So where are we using VGC16? In the crop classification, like whenever we give a crop image, it will detect which crop is it. In that thing, we are gonna use the VGC16 architecture. This mainly consists of 16 layers, which in which 13 layers are the convolution layers, and the 3 layers are the fully connected layers. In this convolution layers, we have various types of convolution in which the input image should be 224 and 220 into 3 RGB channels. In the convolution layers should be of 3 into 3 filters and width of same padding. We also gonna have max pooling layers of size 2 into 2 and stride of 2. And the after all the convolution layers we'll have a flattening layer which will create a 1D flattened array. It should be of the feature map of 7 into 7 into 512. Then we're gonna have the three fully connected layers which are the dense layers. After in the third fully connected layer we're gonna have the softmax activation. So these are the train epochs of the VGC16 architecture. Now to the prototype of the app. This is gonna be how the prototype of the app. So first we're gonna select the image for the Sar image colorization as we selected here. Now when we colorize, we'll get the colorized image. Now when we go for the crop classification, we can select an image, and then when we click on classify image, it will give the class name of the image. Now let us see the sources of this information. So for this R image colorization, we're gonna use a pix-to-pix example notebook in which we have the some of the code for the pix-to-pix, and also the second one is also the code from the Kaggle itself, where we can find the code of how to do it, of the various generator and the discriminator. For the crop classification, we have an code from the Kaggle itself. For the pix-to-pix architecture, it has the all the key model architectures of the pix-to-pix as we have seen in which the learning rate was 0.002 and many more. For the VGC16, we have already we are referring geek for geeks. So thank you. This was Gautam this side for presenting a PPT on remote sensing Gen AI.